Let us discuss about the simple concept that is called the shapes of the atomic orbitals. You know that S, P, D, F, these are the subshells, right? L is equal to 0, 1, 2, 3. So respectively, we are going to get the S, P, D, F subshells. So so this is called, S means spherical shape. Spherical means it's a round shape, right? These are the spherical shape, and we have seen this P shape. P shape is dumbbell shape. P means dumbbell. This is called dumbbell shape, right? So like this will be the dumbbell, like this. This is called dumbbell shape, and this is called the double dumbbell shape. D stands for the double dumbbell. So this is the one dumbbell, this is another dumbbell. So this is called double dumbbell shape. So look at this orbital, that is called S orbitals. So this is 1s orbital, this is the 2s orbital. So that's why it's very bigger than this 1s one, because as the principal quantum number increases, the shell size also increases. So here this is called 1s orbital. So S is spherical shape. So I mean this is the along, these are the coordinates x, y, z. These are the coordinates. So this just indication of the spherical shape. This is called 1s, 2s. Let's discuss about the p orbitals. So p means double shape, right? So this is an px and this is the py, and one more, this is called pz. Coordinate will be x, y, z. So these are nothing but the coordinates. X, y, z nothing but the coordinates. So along the x-axis, that is the orbital called px. See, this is the axis. Along the axis, orbital will be located. Like this also, this is an y orbital. So along this y orbital, so this is the orbital is located here. This axis, along the y axis, that is called py, and along the z axis, orbital will be located. Its name is called pz. So like this, in the spherical shape, only one spherical shape is there. So in p shape, we are going to subdivide it into px, py, z. These are the coordinates. So come to this d orbitals, we are going to split it into 5 orbitals. That is called dxy, dyz, dxz, dx square minus y square, dz square. When you look at about these diagrams, is just you should see the axis, right? This is an y-axis, this is an x-axis. I mean orbitals which are placed in between the axis. So suppose this is an x-axis and y-axis. So between these x-axis and y-axis, orbitals are going to be located. That is coordinate dxy. These are the very important diagrams. So come to here. So along this y-axis and z-axis, so between these two axes, the orbitals will be located. Its name is called dyz. Come to this dxz. So this is an orbital, this is an coordinate, this is an coordinate system. This is the x-axis, z-axis. So between this x-axis and z-axis, the orbitals are located. Its name is called dxz. Then coming to the last two, these comes to one category. So these three comes to the one category. These comes to one category because so these orbitals which will be located in between the axis. What about these orbitals? They are along the axis, like similar here, px, py, pz, as right? So like this also, these orbitals along the axis. So if I take the x, y axis, this is an x-axis, this is an y-axis. Along this x-axis, so orbitals will be located. That is called this orbital and this orbital. That's why its name is called dx square minus dy square. Come to this last one. So this is an 3 axis will be there. So along the z axis, the orbitals will be located. That name is called dz square. So like this. So these are the shapes of the important orbitals. You should remember this one. So in order to write the electrons in the location of the orbitals, so these are the shapes of an atomic orbitals. Let us discuss about the energies of the orbitals. So how it will be their orbitals energy? Let us discuss here. So first one, we are going to discuss about the energy of the orbitals in the hydrogen atom. So hydrogen is, you know that it is a very simplest atom because it contains only one proton in the nucleus and one electron in the orbit. So if I show this one, that is called simple hydrogen atom, right? So this is called a nucleus. Nucleus is nothing but their positive charge will be there. That is called the nucleus. And surrounding this one, electron will be there. One electron will be there and one proton will be there. That is called nucleus, which holds the proton, and the orbital which holds the electron. So due to this one, how it will be possible? Because of the electrostatic force of attraction here, which plays very important role here. So that holds an atom together because of the electrostatic force of attraction between this electron in the orbit and this is the nucleus of that proton. And you know, this energy of the orbitals in the hydrogen is mainly dependent upon the principal quantum number, like this. So this is the simplest principal quantum number. How the increases, how the orbitals which is going to be increases as the number of the principal quantum number goes on increases. So let us take here 1, 2, 2, 3. These are the numbers nothing but the principal quantum numbers. So these are the subshells S, P, D, F, like this will be there. So these shows the increasing in the order of the energy levels in the respective orbitals in filling the electrons in the respective atoms. So here this equation, that is called the same energy. So this is nothing but the same energy of the orbitals. So this we are going to call as the degenerate orbitals. These I am going to call as the degenerate orbitals. And here hydrogen means one electron, that is called, I am going to write as a 1s1. So this is called the electronic configuration of the hydrogen, which contains only one electron, right? So this is called the most stable condition for the hydrogen element, and this is also called the lowest energy. So when you goes on increases the electrons in the orbitals, that orbital energy also goes on increases. I mean, when you take some other elements, right? If you take some other atoms, the electrons will be there. So like this, the order goes on like this. So this is, I am going to explain the simplest hydrogen atom. Let us discuss about the second concept, that is called the energy of the orbitals in a multi-electron system. Just you have seen the in a single electron system, that is called hydrogen, because hydrogen contains the only one electron, right? So where there we have discussed the only energy of the orbitals in hydrogen mainly depends upon the principal quantum number. But whereas in this multi-electron system, what happens? The energy of the orbitals is not only depend upon the principal quantum number, but also assume with a quantum number. You know this one, right? So this is n is nothing but the principal quantum number. So that principal quantum number can be designated as the small letter n, and also L is nothing but the assumed quantum number or subsidiary component numbers. So this indicates the subshell. This L indicates here what? This is called subshells. Is called the subshells. What about this N? N is indicates the main shell, right? So this multi-electron system, energy of the orbitals depends upon this principal quantum number as well as this azimuthal quantum numbers. For a given principal quantum number, given values, so these subshells means, you know this one, S, P, D, F, like this. So these are called as the different orbitals. When they are called as the different orbital means they must have the different energies. Why this is? Because of the reason is like this. The mutual repulsion between the electrons within an atom. Mutual repulsion means, suppose if I take any, consider I am going to take any atom, right? So this is, I am going to take this any atom, right? So you know this one, this is called center, it is called nucleus, right? So nucleus is consists of the positively charged, right? So this is called the proton, right? Positively charged, this is called proton, and there will be negative electrons will be there. Just electrons, they are going to be revolve around this nucleus, right? So what happens here? One parameter says that the electrostatic force of attraction between positively charged proton and negatively charged electron, that holds the atom stable, right? But also simultaneously, so many electrons will be there. What happens? The mutual repulsion. This is called mutual repulsion between the electrons within an atom. Repulsion will be takes place like this. Attraction means they are going to attract. Repulsion means they are going to far away because of the mutual repulsion. So that's why in the multi-electron system, the energy of the orbitals not only depends upon this shell, but also subshells. Subshells means S, P, D, F. Because of the different orbitals, different shells, they are also having the different energies. And this concept, shielding effect of the inner electrons. So this is very important concept. This is called very important concept. Let us study in separate and in details.